So guys, Chorwe, I've not seen your work. Pedro, I haven't seen your work. I've just seen the work for Juanita and Trish. And I remember emphasizing the point that when work is given, and it's class time, only those who have done the work are the ones, meaning are the ones who are ready for the next class. Let us be serious. Otherwise, we'll spend 2 days, 1 week, 1 month doing this thing, and at the end of the day, we will not appreciate it because we are not doing what is supposed to be done. When work is given, like I said, please hand it in. Let me have a review of the work. Then I'll be able to advise whether you guys have understood that we should go on with the next set of work, or maybe there's need to go back. So I'll teach you today. Tomorrow, when the work I will send you don't do it, I think it's better you don't join because it means we are not moving together. So today I want us to look at the definite integrals. Like I explained the other day, that something definite, it's something exact. So these types of integrals have got definite answers. And like I said, that integration is the opposite of differentiation. Now, integration has got two parts, which we looked at in the previous discussion. The first one is definite integral. The second one is indefinite integrals. So the first presentation, we looked at indefinite integrals. And now we are here discussing definite integrals. What are they? What makes it different from indefinite integrals? So first of all, I have to make mention that integration has got this symbol, the symbol for integration, like I'd said, it looks like an S, but the way it is curved, it's different from the actual S. That's the symbol for integration. Even when you go on the Microsoft Word, this symbol for integrals, it is there. Now, the difference between indefinite and definite integrals is that for indefinite integrals, at the end of the integration, we were saying plus c. This c represents a constant of integration, which is a number in the function which does not have an x, which after doing the dy dx, that number gives us a 0 and it does not appear in our final answer. But for definite integrals, we have some numbers that are written here, another one written here. These numbers are not there when we are dealing with indefinite integrals, only when you are dealing with definite integrals. Now, this number, what does it mean? That's one thing I want you to understand. This thing, what does it mean? And this thing, what does it mean? This number that is written up, it's called the upper limit. This number that is written here is called the lower limit. Let us say you have, a graph in an x or y plane, and then they say this is a graph that we have. I'm just giving an example on how these limits are applied. Let us say this is a graph. This point here will give us x1. This point here will give us x2. And when you compare x2 and x1, x2 is bigger than x1. In that, this one is on the upper side, this one is on the lower side. So if So in a moment you have this here where we have x1 here. That is where we have the lower limit because this value is smaller than the x2. And the x2 here is where you put here as the upper limit. So this is only the application of definite integrals when you are finding the area. When you're finding the area, we use definite integrals where we get the first x here as x1, which is called the lower limit. The x2, the larger value, is what you put here as the upper limit. So this is where these limits come from. I was just trying to give you an insight on where these values come from and things like that. So how do you solve it? Meaning when you are solving a definite integral, when you are solving a definite integral, solve as if you are solving an indefinite, the same procedure. The only difference is that we do not add a plus c. What we do, we get the upper limit here, we get the upper limit value, we substitute in our answer. For x values, we substitute minus the lower limit, which is here. You also substitute here, and then you find the value. That value you'll find, you get to find that it is a definite answer because this is a definite integral. I was just trying to prepare the background. Let's look at 2 or 3 questions. The first one is this. A, evaluate the upper limit that we have is a 5. The lower limit that we have is a 2 of the function 3x squared plus 2, then dx. This is a question that we have. So remember what I said, when you're solving this question, solve as if we are solving definite integrals. The only difference is that we're going to put the brackets. We're not going to say y is equal to, we'll put the brackets like this, and then we integrate. Remember what we said, how to integrate. We say power plus 1. The same thing will be written. So we'll have 3x, the power 2 plus 1, which is power 3 over 3, plus this 2 is written as 2x power 0. So we are saying plus 2x, because the coefficient, when we add the 1 and we come and say 0 plus 1, is still giving us 1 in either ways. When 1 is a denominator, even if you don't write it, it's okay. When 1 is a power, you don't write it, it's fine. So that's how it is giving us this. We are not saying plus c. We'll just keep now our limits, the upper limit and the lower limit. And remember, these 2 things can cancel out. When these things cancel out, you'll find that what remains is actually 3. It's x power 3 plus 2x. With these limits that we have, the upper limit 5, the lower limit 3. What do you do with them? I said you substitute. So where there is x, we are putting 5, which gives us 5 power 3 plus 2 multiplied by 5. This is the substitution of the upper limit minus substitution of the lower limit. This is 3 power 3. Oh, it's a 2 rather. Sorry, it's a 2 here. So we'll put a 2, the upper limit, the lower limit. So we'll put a 2 here. So we have 2 power 3. We are just substituting x. Where there's x, we are putting a 2. And then we have a 2, which is multiplying an x. So we'll have a 2 here, which is multiplying our x this time around is a 2. So when you compute here, 5 raised to power 3, it's 5 times 5 times 5, gives us 125. 125 plus 2 times 5 here gives us 10. This is what we have on the upper limit. Minus on the lower limit, 2 times 2 times 2 gives us 8. Minus, plus rather, 2 times 2 gives us 4. Then what do? We can come this side here. 125 times 10 gives us 135 minus 8 plus 4 gives us 12. And when you subtract 135 minus 12, the answer is 123. So 123 is the answer. So the only thing that you have to do is integrate. When you integrate, keep the upper limit, keep the lower limit. When you find the answer, then get the upper limit, substitute where there's x, find the value, get the lower limit, substitute where there's x in the same function, then later on we always subtract. You find the value and you find that the answer you will find is an exact answer because this is definite integrals. Any question?
No.
The next question. The next question is saying the integral, the upper limit is 3, the lower limit -1 of 3x squared, 3x squared minus 2x, then dx. Starting from the time we are opening our online learning, will be better for those who still stick around because by then I will have gotten the pencil for the iPad. I'm planning to get an iPad as well as a pencil so it becomes easy for me to write. Otherwise, writing using a cursor for the laptop has been a little bit of a challenge. That's why even typing I use the keyboard. But if I have a pencil, I can even write using a pencil handwritten. So the similar manner we are going to find the integral. So the integral, now when you have done much of these things, you don't even need to show that we are adding a 1, we are doing what and what. Right from here, you will know that the answer here is x power 3. Right from here, if you have done much of the calculus, you find that You don't even need to do much of showing this and that. You just go direct from the question. You already know the answer because you know what was happening. You are adding a power. So the adding of a power, dividing by a power, reducing, all that you can ignore because we have done much more of it. But because we are learners, let's see. So we are saying 2 plus 1, which gives us a power 3. The coefficient which was here is 3, which is divided with another 3. That's how I just ignored these things just to save time. And then minus the 2x, the power is 1. So to that 1, you add the 1, you're going to have a 2. So that 2, you come and divide with a 2 here. It's also cancelling. We're just remaining with x squared. Now here we're not saying the x. The moment we have done the addition of the 1 to a power, dividing, you just indicate the lower and the upper limits. Our upper limit here is a 3. The lower limit is a negative 1. Our lower limit is a negative 1. So in a similar manner, we are substituting. Where this x, will put our upper limit, where we'll have 3 power 3 minus 3 squared. This was a substitution of the upper limit. So minus the substitution of the lower limit, we have our negative 1, which is multiplying 3 times, or which is multiplying 3 times. We subtract our negative 1, which is being multiplied 2 times. This is what we have. So we'll have 3 times 3 times 3, which gives us 37 minus 3 times 3, which gives us a 9. Gives us a 9. This is the substitution of the upper limit minus the substitution of the lower limit. When a negative 1 is multiplied 3 times, the negative comes back. Because negative times negative, positive. Positive times negative. Once it is multiplied the 3rd time, then the negative persists. So this is what we have. Minus, here the negative 1 is being multiplied twice. Therefore, the answer is positive 1. But there is already a negative here. That is how the answer is coming out to be negative 1. So this negative 1 that we have here is because the negative was being multiplied 3 times. Then this negative was dropped here. The negative in the bracket being multiplied 2 times, it turned out to be positive like that. So when you compute 29 times, 29 minus, rather, 27 minus 9, you'll find that the answer you are getting is 18. So the substitution of the upper limit gave us 18 minus, inside of what we have in the brackets is negative 1 minus 1, which gives us negative 2. And what do we know? When two signs are following each other, separated by the bracket, we multiply. So here, we are multiplying a negative and a negative, which is giving us a positive. As a result, we are adding 2 plus 2, which gives us a 20. So 20 is our answer. So you'd find that if you understood the indefinite integrals, when it comes to definite integrals, these will be actually the simplest of them all. This will be the simplest of them all. Do we have questions? Questions, guys?
No.
Yes, Trisha, my dear.
Sir, can you kindly explain again how you multiplied the signs inside the bracket of -1 minus -1? I didn't get it there.
Thank you. So,
Thank you.
what happened was this. Allow me to rub everything. Yeah. Um, what we have is this. Our upper limit is 3, which is positive, so we'll keep it that way, that the 3 is being multiplied 3 times minus the same upper limit is substituted because we have an x, which is 3 power 2. Then we close the bracket minus the lower limit, which is -1. This -1 is being multiplied 3 times minus our lower limit again being substituted by a -1 is being multiplied 2 times. Now, -1 times -1 times -1 for the third time. What are we getting? This is what we are trying to explain. That -1 times -1 will give us a +1. So now when you have this +1 multiplying with a -1, we will say negative times positive times negative. The answer is negative. Negative. That's what we did here. So quickly, 3 times 3 times 3, that is 9 times 3, we got 27. We got 27. That's why is it escaping? We got 27 minus 3 times 3, we got 9 for the substitution of the upper limit. Now, when we came to the lower limit, I said, when you raise a negative power, now let me change the scenario, which is an easier way. When you raise a negative power to a number which is an odd number, this is conclusively. When you raise a negative number to a power which is an odd number, the answer is always negative. That is why we are saying -1, because a 1 being multiplied 3 times, a 1 being multiplied 3 times, it still gives us a 1. Now, because this negative was being raised to an odd number, it comes back to be negative. This negative comes back here, minus. When a negative is being raised to an odd number, it gives us a positive. So this thing that we have here gave us a 1. And that is how the -1 minus 1 gave us a -2. We already have a minus here. So this minus here was just transferred in its original state. This minus here was just being transferred here. And our 27 minus 8 minus 9, that's what gave us an 18. That is what is happening. So, any other question?
No.
Can we move on?
Yes, we can.
So the last one is this one. The last one is the integral, the upper limit 1, the lower limit 0 of the function x squared. I want you to pay attention. X squared minus 2x minus 3 dx. Let's integrate it. Our integration is now going to be a bit advanced because we have done much more of integration. So we understand that when we add the 1 there, it becomes a 3. So we are going to say x power 3. X power 3, the same power is going to be written as our denominator, minus. Here, a power is 1. We add the 1, becomes a 2. We come and divide with a 2. The 2 and the 2 will cancel. We'll just have x squared minus 3x. We understand that the x at the power, which is 0. So to that 0, we add the 1, and that's how it is coming out like that. So this is our answer. Then we substitute. We get our upper limit. We put a 1. 1 power 3 divided by 3 minus, it's a 1 being raised to power 2 minus, it is a 3, we are multiplying with a 1. Now, they will tell you that whenever the lower limit is a 0, whenever the lower limit is a 0, do not even bother yourself subtracting anything because everything is coming out with 0 for as long as x values are there. But let's see. We're going to say 0 power 3 over 3 minus 0 squared minus, you see what I'm saying? 3 times 0. So our right hand side, the answer is just 0. That's why it's canceling. So here on the left, what we have is 1 over 3 minus 1 raised to power 1 is just 1 minus 3 times 1 is just 3. This is subtracting a 0 because when you say anything here, it's a 0. Divide by 3, it's a 0. Here it's a 0. Here it's a 0. So here we are going to have a 0. And then we're saying it's equal to 1 over 3 minus -1, -3 will give us -4. So here it's just a common fraction that even a grade 1 can do. Where we say, we can come this side, where we say our common denominator is a 3. So 3 into 3 is 1. 1 times this 1 gives us a 1 minus 1 into 3, it is 3. 3 times 4 will give us 12. And what will be the answer? The answer will be -11 over 3. That is what our answer will be. So unless there are questions, otherwise you'll find that the definite integrals are very simple for as long as you understand what is happening with the indefinite integrals. unless there are questions. Questions? Okay, if there are no questions, allow me to record whatever we have discussed. I send it over and then we have a bit of a small work. Is that is okay?
Yes.
All right, thank you.